Oh, here we go with this very exciting adventure of systems of equations. This is the peak of our eighth gradeness here. So, if you're checking this out, great. That's totally awesome. Any sort of reinforcement for this is good. This is the most mathy of mathy things we'll do all year, and is the thing that will most prepare you for next year. So let's do this lesson. It's the first lesson in this unit. All we're going to do in this unit is we are trying to figure out what type of solution a system has without doing any math. So we're just trying to check to see what these equations look like and what they might look like if we graph them. So essential question then is, how can you determine the number of solutions for a system of equations? Now, I know what you're thinking, like, what's a system of equations, right? This is brand new. So when we talk about a system of linear equations, so we're talking about lines here, what we're talking about is two or more, but the reality is we really don't do or more. We really just work with two. Two linear equations where the x and y, or input and output, are the same. Okay, what does that even mean if we just say they are the same? So if I write this equation here, y equals 2x plus 5 and y equals negative 1/2 x minus 13. Now when I write those equations, some places will show you a little curly bracket around that. We don't necessarily do that because we're assuming in a systems of equations unit that this is a system. That these two lines interact in some relationship to each other, but also that each of these x's are the same in both, right? Therefore, at some point, the x's and the y's could be the same in both equations, right? These variables represent the same things in those things. There are three types of solutions for this. The first type is the most obvious, one solution. One solution when we're doing inspection is that we have a slope that's different in each equation. Two different equations, two different slopes. As soon as we know that happens, then one solution happens, and that happens at an intersection. And we'll look at that in just a minute. That's where two lines crash into each other. The next thing that we have, next type, is no solution. Now, when no solution happens, we have two lines that are parallel. And by that I mean they will never intersect with each other. We can see that because they have the same slope, but different y-intercepts. So just looking at the equations, same slope, different y-intercept. Then lastly, we have many solutions. And many solutions is the tricky trickster, right? Because many solutions is when we have the same line twice, right? One line and then the exact same line. And what happens is, they usually get disguised like that. They have the same line, which means we have the same slope and the same y-intercept. So I wrote them as m and b this time. Yeah, and then as soon as you graph it, we only see one line on the page. Okay, let's look at the examples here for the types. Looking at here, we've got an intersection, which means we're going to have one solution. First thing to always check is, are both equations in slope-intercept form? When I look at the equation here, y equals x plus 4, y equals negative x plus 6. The answer is yes, they're both in slope-intercept form, which means we can check to see what these look like. The slope of the first equation is 1. The slope of the second equation is negative 1. Are those the same? No, they're not the same, which means we have one solution. And then if we want to know that solution, what we're looking at is where those two intersect. So we write that as an ordered pair, and we say 1, 5. Let's look at the second one. In the second one, we have two lines that don't intersect. Let's answer our first question. Are both equations in slope-intercept form? Well, I've got y equals x plus 3, y equals x plus 1? Yes, they are, which means we can compare them. Now, if we look at the slopes, let's check the slopes. The slope is 1, and the slope is 1. Those are the same. Let's look at the y-intercept. In the first equation, the y-intercept is 3. In the second equation, the y-intercept is 1. So what does that mean? We've got same slope, different y-intercept, which means we have no solution. We have no intersection. These two lines will never intersect. These two lines will never intersect like these do. So there's no ordered pair where they connect. Finally, we've got the last one. Wait a minute, there's only one line on it. That seems weird. Are both equations slope-intercept form? No, they're not. All right, when we look at this, I've got x plus y equals -2. Now, we've practiced this a little bit, but I've rewritten this now in slope-intercept form. My other one is 3x plus 3y equals -6. 3y equals -3x minus 6. Y equals -x minus 2. Well, howdy do. Look at that. The slopes are the same, the y-intercept's the same. What that means is we have many solutions. When we graph this, and we can see it in the graph, many solutions. We can see it in the graph. They both graphed as the exact same line, which means every single order pair we could write from that line would make both these equations true. Okay, so down at the bottom here, we've got how can you use slope-intercept form to identify the slope and the y-intercept of the line? So we use that because M and B, the slope and the y-intercept, are easy to identify. They're right there for us. Then, if two lines have the same slope, what are the possible numbers of intersections they could have? Well, there's two things that could happen here. One, we could have no solution, so there are no intersections, or we could have many solutions, which is like all intersections, right? So no solution would be like no intersections. Many solutions is it's just constant intersection. These will never meet. These are constantly met. Okay, let's go to page 2. Page 2, let me find my paper. Here's my paper. Let's bring in the word problems. Here we go. All right, in example 2, we have a situation with some comic books. Harrison and Pia each buy X comic books. Harrison also buys an action figure for $15, while Pia buys a different action figure for $12. Could they each spend the same amount, Y, and buy the same number of comic books? All right, let's look. So just so I can keep this straight, and this always helps. Labels are wonderful because then I don't have to remember anything while I'm doing this. So when I set that up like that, now I have Harrison. How much did Harrison spend on comic books? Well, we don't know. That's this part right here. But we know how much a comic book costs because Tricky Trickster, this book says it's $5. You got to look in the picture. So he spent $5 per comic book. Pia spent $5 per comic book. So what's going to go here? What goes here for Harrison? Very good, right? He bought an action figure for $15. So there's his $15. And then what's going in there for Pia? Of course, she spent $12 on an action figure. Now, when we look at those two things, now we can start comparing slope and y-intercept. What does that 5x represent at this time? Well, we know that what it is the cost of comic books, right? And we know that it's not complete. We just know that for every comic book they bought, it was $5. So if the two of them bought 2 comic books each, $10 and $10. 3 comic books, $15 and $15. Why are the slopes the same, but the y-intercept's different? Well, the slopes are the same. There, I'm giving you a chance. Pause it if you need to. The slopes are the same because the cost of comics is the same, right? But why are the y-intercepts different? They bought different action figures, so that extra charge is not the same for both people. different action figures. If we go back to our definitions of how we do this, which one would we have? One solution, no solution, many solutions when we look at this? Well, just check. We're looking at slope first. Are the slopes the same? The answer is yes. Are the y-intercepts the same? The answer is no, which means we have no solution. There is never a time when Harrison and Pia will spend the same amount of money. Let's look at our last example. We are going to estimate more solutions by inspection. So this one's going to be a many solutions because that's the way this works. Corey and Winnie each bought X pounds of cheddar cheese. I better write that down. X equals cheese. And Y pounds of tomatoes. Y equals tomatoes. Tomatoes. Corey spent $12 at the supermarket. Oh, here's Corey. Winnie spent $24 at the farmer's market. All right, 24, Winnie, 24. Could they have bought the same amount by weight of cheddar cheese and tomatoes? Well, let's figure it out. Who knows? We can see. We've got to write an equation here, and we know that Corey spent $12 total. She bought X number of something and Y number of something, and you add those prices together. Cheese is X. We don't know how many pounds of cheese she bought, but we do know how much each pound of cheese costs. Check your thing. Now, reading is fundamental. Reading's important here. The cheddar cheese is listed second, but it is our X. Tomatoes is 2. There's our 2. Don't just take for granted that things go in an order that you assume that they go in. Winnie spent $24, and we know she's bought some cheese, and we bought some tomatoes. We don't know how many. Her cheese cost $12 a pound. That's some fancy cheese. And her tomatoes cost $4 a pound. Now, neither are these in slope or intercept form, so that's where we've got to make this change. Let's subtract 12x from both sides. And I get 4y equals negative 12x plus 24. Divide by 4, divide by 4, divide by 4. And I get y equals negative 3x plus 6. All right, let's check Corey. Minus 6x minus 6x. I get 2y equals negative 6x plus 12. Divide by 2, divide by 2, divide by 2. Here we go. Y equals negative 3x plus 4. No, not 4. 6. There we go. All right, let's check. First, check our slopes. Are they the same? Yes. Check our y-intercepts. Yes. So then no matter how much they bought here, we don't know exactly, but they did buy the same amount because we ended up with the exact same equation. So no matter what, the technical solution is many solution, but we do know that they each bought the same amount of cheese and tomatoes. Easily the most exciting day in math that I've ever had. All right, if you try the practice, check your answers, check in with me if you need to, find me during the day, it's totally fine. I can answer questions at any time. Good luck!